Okay, so ladies and gentlemen, this is a recording. I'll ask that you are exceptionally quiet right now. And this is for Wednesday, 10:31. And so I will be going through things. If I call on you, I'll try to not use your name, and I'll just like point to you or tap on your desk or something. So just be aware of that. This is notes for 1-4, and we are hoping to get through this section today. And we used a graphing calculator already. You know that both homeworks 4A and 4B are due on Friday. On Thursday, juniors will be taking the STAR test, and seniors will have maybe a short in-class assignment and then some work time in addition to that. So we used our graphing calculator before. We're going to do that again. I have this one set up because I'd like to go a little bit more quickly through this particular problem. And this is what it says. Approximate to the nearest hundredth the relative or absolute extrema of f of x equals x to the fourth minus 5x squared minus 2x plus 4. And then you're going to state the x values where they occur. As a matter of fact, we will state them as ordered pairs. So if nothing else, you should also note to yourself that there is sometimes a little bit of confusion for people because we do a lot of intervals and now we're doing also ordered pairs, right? So we just kind of have to know what we're talking about. And an interval and an ordered pair can look very the same. 4,3, do I mean I'm going, oh, just kidding. No, not 4,3. 4,6, does that mean I'm going from 4 to 6? Or does that mean x is 4 and y is 6? So, you know, sometimes we're just going by what is happening here. And for us, it says you can kind of do that, maybe tracing along there or whatever. We know that we have access to a graphing calculator and that it can find those zeros or excuse me, extrema values for us. So type in x to the fourth minus 5x squared minus 2x equals 4. And you can graph that one quickly as well. And our other one yesterday was like negative x to the fifth, I feel like. And so this one's a little bit different, and or maybe, yeah, I don't think we had exactly this one. So take a minute, graph that. Because I feel like we focused enough on the graphing of things yesterday, I'm just going to show you what mine looks like. Here it is. And just a reminder, my expectation is that you have your own graphing calculator in the room. Oops. And so the graph looks like this. And, oh, maybe, there we go. Maybe we graph this right at the end of the hour, and maybe that's what you're thinking now that I'm looking at that. And so it has a minimum there, a maximum there, a minimum there. This is a relative minimum. This is a relative maximum. This is an absolute minimum as we look at that. And so I am going to also take a picture of that. And so here it is, and our graph just looks like this. Oh, that is very loud in my head. And so there's that picture. Then you just know how to find those values as you go. And so maybe I'll do one of them. I'm going to second calculate. So it's on that blueprinted. I'll do a minimum first. And it asks me for the left bound, just like we've talked about before. You always go from left to right on a graph. If you try to go from the right to the left, it will not allow you to do that. And so when you feel like you're to the left of that, you can press enter. And then when you feel like you're to the right of that, you can press enter. Now, your calculator is not smart. It actually just calculates a bunch of values. Did we learn the intermediate value theorem? I feel like we did. The intermediate value theorem, if this one at y is here, the other one's there, it has every y in between those. So all it does is the intermediate value theorem repetitively finding X values in that interval and narrowing its interval down. So when it asks you to guess, it just makes less work for the calculator if you try to arrow to close to that, and it just finds that a little bit more quickly. And then here's our minimum value for that one, and so we'll put that, yes, also on the smart board. And then you can find those other two as well. Second, calculate, the maximum is number 4, and again, finding your interval. I'm not going to find all of these for you. You should have a calculator. If you don't, just consider yourself, you know, I'm ill prepared for what I have to do today. And kind of try to be more prepared as you go. So I have 2 of those. Take a moment, find that other one as you go. The directions here say to approximate those to the nearest hundredth, and so hopefully you're finding that other one as well, and then I'll ask some people to kind of tell me these to the nearest hundredth as we go, and tell me what they are. So, and let me see if I can find my marker. Evidently, I set it down someplace. Does anybody see my marker? Okay. That's all right. Doesn't matter. Oops. Oh, I see it. Thank you. Thank you, Emily. Okay, so there we go. I need to know what kind of an extrema value this is and what it is to the nearest hundredth as we look at that. So Kelsey, I'm going to ask you for that first one that we found, what kind of an extrema value is it, and what is its ordered pair coordinates? No, I want the actual, like, you know, the XY value to the nearest hundredth. 10th hundredth, 2 decimal places. 1.47, negative 1.47. And what's the Y value? 0.80. And since we're going to the nearest hundredth, and it wasn't like, you know, a 0.8 that was exactly that value, then we do include that 0 as we go through that. And then Colin, what would you call this next one here? And that's a relative maximum. And rounded, what is it going to be? And 4.20 as we go. And then I need the other one. Gabe, did you get that other one? The last one here. Okay, I need that one next. Kaylee, do you have that one? Okay. Is there anybody who has that next one? Yep. Okay, the last one here is an absolute. And what are its ordered pairs?
The X value is 1.67, and the Y value is negative 5.50.
Is it 0 or 1? Okay. Okay. 5.5. 1. Okay, so these are ordered pairs, and that's what we were asked to give, is just what those extrema were and in their approximate values as we go. And we have access to a calculator, and so that is what we'll use as we go. I have another one for you to do, and with your calculator, and this time I'll just ask that you try to find that, and I'll give you a few moments moments to do that, and then we'll move on. This is optimization, and that's an application of mathematics where one searches for a maximum or a minimum quantity given a set of constraints. And this is a very, straightforward optimization problem because we only have one function that we're looking at. If a set of real-world quantities can be modeled by a function, the extrema of the function will indicate these optimal values. So advertisements for new car claim that a tank of gas will take a driver and 3 passengers about 360 miles. After researching on the internet, you find the function for miles per tank of gas for a car is f of x equals negative 0.025x squared plus 3.5x plus 240, where x is the speed in miles per hour. What speed optimizes the distance the car can travel on a tank of gas? And how far will the car travel at that optimum speed? So take a minute, put that in your calculator, and what I want to know first is a window. I'm coming around to see your calculator. I want to see a window because if this is going to have a maximum value, I'm expecting to see that, right? I'm expecting to see that, and I'm guessing negative 10 to 10, and negative 10 to 10 is not going to do that for you. So take a minute and see what you can do there. Do you have a window? I want to see it on a picture of it. Oh, very nice. Yeah, that's a pretty good window. I'm just gonna, okay, yeah. Those are estimations too, so yeah. Yeah. I'm seeing a lot of different windows, but good windows at the same time. So who would share kind of their window? Somebody who has, I can see the peak for sure. So what is your window from? No, low to high. Oh, okay, got it. Negative 500 to 500. And did you go by ones or tens or I don't know? Okay, if you go by one, you don't like see much for grid work marks. And sometimes if you have a super big range there, one doesn't work because it's like it can't count by one, just to let you know. And then what was your Y window? Negative 500 to 500 and by ones. So this is the x-min of negative 500, x-max of 500, and going by x scale or delta x or whatever it happens to say on a calculator, I forget, by 1, and then negative 500 to 500. So you should have that there now. And now find that point that is going to be the maximum. So find where that maximum point is as you go. Find that maximum point. And then you have to kind of interpret that as well as we go. And who can tell me what that maximum is? Does somebody have it yet? Go ahead. Oh, yes, I was pointing, but that's okay. So our maximum value is when x is 70, and then Kelsey, what's y? And so then we want to interpret what that means. So what does that mean? What does that mean in terms of this problem? Eric, go ahead and tell me your interpretation. Okay, so if you travel at 70 miles per hour, the car will, let's see, should I say will go 362.5 miles on a tank of gas, And so that's what you're doing in this problem, kind of that optimization problem as you go. So I just wanted to take a little bit of time, since we have a graphing calculator, even when it's asking us to estimate those, if you want to just visually look at the graph and try to figure it out, that should be acceptable. But you have the graphing calculator, put it in there, see what you get in order to do that. Now, our next thing is the average rate of change. And truly, if you can find, how many, raise your hand, because I never have you raise your hand. Raise your hand if you can find the slope of a line given 2 points. We can all do it. Then I don't know why, but somehow people then average rate of change, because that's really all you're doing, but people struggle sometimes with average rate of change. And so here is that value. There's my window on this calculator screen by the book authors. So average rate of change. What's happening for average rate of change is we are taking a curve and we are forcing it to have a slope kind of rate of change. That's essentially what we have. So keep in mind, this curve has all kinds of slopes, right? It has positive, high value of positive slope, high positive, and then it's leveling out, and then it's going to start having a negative slope, right? So it's very dependent on what 2 points we pick. If we pick 2 points, then it's going to have, a very different slope than if we pick a different set of two points. But essentially, here's what it's saying. If my first x value is there, my second x value is there, on average, because it's going from there to there, on average, that's going to be my rate of change. That slope is going to be my average rate of change. And so that's what we're kind of looking at in this one. So you want to have an idea or concept of average rate of change, and you also want to know that it's using a secant line. Did I talk about secant line yesterday? I feel like in my head I did. Okay, tangent line hits something once, secant line hits something twice. So an average rate of change between any 2 points on a graph of f is the slope of the line through those points. So I've got 2 points. My deal here is, mathematically, I would love to be able to just do that without actually having to find an x and a y and an x and a y, just kind of putting it in my rule. The average rate of change between any 2 points is the slope of the line through those points. That is all it is. That line is called the secant line. And it's m SEC. It's M for slope, that's familiar to us, and SEC for secant. And so this is how we find the average rate of change on an interval. And notice how it's giving this. And that's a little small, so I'll also write it here. If our interval is from x1 to x2, notice I'm using brackets. So did I say the right word? I'm using brackets because I'm saying from x1 to x2, I'm counting x1 and I'm counting x2. And the slope of the secant line, m secant, is f of x2 minus f of x1. Let me just write that a little better. F of x2 minus f of x1 divided by x2 minus x1. Now, Professor Ouija, when he was here talking to my pre-calculus students, and that just is who he is, he said, if you can do algebra, you can do any college level math class. And I took a little bit of issue with that, but here's what I think he means. Okay, so if you have to, okay, are you ready? If you have to get that as an ordered pair, like, 3, 5, and you have to get that as an ordered pair, maybe 5, 2, or whatever it is, and then you have to find the slope that way, you're not ready for college math. But if you can take the rule, here's the difference in what he's truly saying and what you might think he's saying. If you can take the rule for f of x, and you can take f of x2 and subtract f of x1, and then take x2 minus x1 and just kind of do it as the rules and manipulate all that algebra, that's the kind of algebra you want to be able to do well. And the problem students have with this is that's going to be a rule and you have to subtract that rule. So what does that mean about that subtraction sign? It has to get distributed through that rule. That's why, but know this, as a student in a high school math class, if you have to put x2 in and get that y value, put x1 in and get that y value, and then take y2 minus y1 over x2 minus x1, you're doing high school math. You're finding slope, and that's good, and that works. So if that's how you're going to get it right, by all means, do it that way. I'm going to do it the hard way right now, but I'm going to convert to, and say, if you have to do it the other way, by all means, do it the other way, because really, that's kind of what we have to do. So here's the secant line. It says find the average rate of change of f of x equals negative 2x squared plus 4x, plus 4x plus 6 on the interval from negative 3 to negative 1. So here's what I'm going to say. First, I'll write the problem, so that kind of slows me as you write the problem. And then I'll say I want the average rate of change. And on the interval, sorry, I had to spell that, from negative 3 to negative 1. So in my mind then, that means x1 is negative 3, x2 is negative 1. And we all agree for ordered pairs and slopes, it doesn't matter which ones I pick as the ones as long as x1 and y1 match and x2 and y2 match, but I can interchange them. So our midpoint, our slope of the secant line is f of x2 minus f of x1 all over x2 minus x1. I want you to be excellent at the algebra so that you can do any math class they offer at a school like SMSU. And I think everybody in this room is capable of doing that. But it's practice that you need. One year we had engineering students come here, and the engineer, as their senior project, and kind of did a little activity with some of our students. And one of they were senior engineering students from MSU, and one of them brought some of his notebooks, and his notebook is filled with kind of problems like this and higher level, but kind of showing what what all that work is. So that's how we kind of have success in the end here. So I have f of -1. So I'm putting -1 in here. So -2 times -1 squared plus 4 times -1 plus 6. I'll color code it as I go. And then the tricky part is I'm going to subtract f of x 1. So I'm going to put that probably in a bracket because I'm going to have a lot of parentheses. -2 times -3 squared plus 4 times -3 plus 6. And that's all of that. And then it's over. And then x2 is -1. And then minus x1, which is -3. Okay, I'm hoping some of you are really good at arithmetic because I would say that is my weakness, is arithmetic. I love math, but sometimes arithmetic I'm not always great at. So follow along and let me know if I make a mistake. So I have -1 squared is 1 times -2, so that's -2. Oops. 4 times -1 is -4 plus 6. I'm not going to overstress myself as I go. I'm going to leave that. I'm going to do this. -3 squared is 9. 9 times -2 is -18. 4 times 3 is 12. It'll be -12 plus 6. So I've got all that going on. This one is plus a positive, so I might as well just figure out what that number is. 1 plus, or -1 plus 3 is 2. Okay, so I think I'm good so far. We'll see if I don't make a mistake as I go. Now, this is all numerical values, so I can do it kind of however I want as I go. I might distribute that and just see what I get. Let's see. Oh, -6 plus 6. What is that? 0. So I might as well, that worked out well in my head. Then maybe I will distribute this. So I have plus 18 plus 12 and minus 6. Oh, over 2. And so 18 and 12, 30 minus 6, 24 over 2. And so our m secant, secant should be 12. Hooray, it's right. Now, think about this. I could have, well, really, if I wanted to be super lazy, and I just have to say it that way, lazy, if I wanted to be super lazy, I could put that in y equals, right? And I could make a little table, and actually those are close enough. I could probably see both of those on the table, and I've got my x1, y1, my x2, y2. And so I could have found each of those, and then when I find my secant, let's see, I know that first one was 0, right? I'd have 0 minus, and then that must have been -24, right? And then divided by -1 minus 3. So that would give me 24, oops, minus -3, over 2, which is 12 that way. And so, you know, that's just, if you want to do this, awesome, because you're going to get the right answer. But if you want to do this, then you're practicing the math and kind of getting better at that as you go. So the next one has the same function, different interval. And so find that answer, show me what it is when you have it. So find that answer, show me what it is when you have it. Yes. I. Oh yeah. No. 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 Is that it? Yeah. It's a number, no variable, and it's not that. Anybody else have a number for me to check? Oh, yep. Do you agree with me so far? Okay, so I'm going to do it the hard way just to kind of get the numbers out there and see what happens as I go. And is there anybody else who wants me to check something? It is an integer, positive or negative whole number. It's an integer. Because I would consider that x1 and x2. Oops. And x2. But you know what? Actually, well, wait. It works out if you do x of f or f2, f of 2 minus f of 5, as long as you do 2 minus 5 there. You'll just get negatives there and, yeah. Do you ready for me to look at it? Yes. Okay, so let's look at it and kind of see what happens. And so I'm just going to leave that there, and then I'll put more in here. So I have negative 2 times 5 squared plus 4 times 5 plus 6 minus, and then negative 2 times 2 squared plus 4 times 2 plus 6. And we just said it's all over 3, right? Okay, so, and I'm going to try to do it so that I get the 2 answers. So if you did it that way, 25 times negative 2 is negative 50 plus 20 plus 6. And so I'll do that in a minute. And then I have minus, and then 2 squared is 4 times 2 is 8, negative 8 plus 8, plus 6 as I look at that one. And then all over 3. And I've got to quit changing colors because then I keep having to do that. So negative 50 plus 20 is what? Negative 30. Plus 6 is negative 24. Okay, so I've got negative 24 minus, and then these are cancel at minus 6 over 3. And so I have negative 30 over 3 or negative 10. And so if you found these as f of 5, which was negative 24, minus f of 2, which is 6 over 5 minus 2, that's what you're going to kind of do on that one. And so it is just finding that ordered pair x and y and kind of figuring out what they are, but it is a little bit tricky. So then we have a real real world application problem, I think, or something like that. So this is a gravity problem. The formula for the distance traveled by falling objects on the moon is d of t equals equals 2.7 t squared, where d of t is the distance in feet and t is the time in seconds. Find and interpret the average speed for the object for a time interval from 1 to 2 seconds. And I'm just going to tell you that there's two problems in this related to this equation. And so I think we'll do this one a little bit differently. And so this is d of t is equal to 2.7 t squared. I will need some calculator help. Oh, maybe. Well, I guess I can do it right now. So it's along the interval from 1 to 2. And so this is x1. And I always want to say y1 because I'm just so used to it. That's x1 and x2. So I'm going to take the m secant is f of 2 minus f of 1 over 2 minus 1. And I'm going to do this one a little differently. I'm just going to find f of 2. So f of 2 is 2.7 times 2 squared. And note to self, just somewhere in my life this year, so it's some people in some class, it may not be this class, but do remember, I can't multiply this and get like 5.4 and then square that. That's wrong, right? I just square the 2 and then I multiply it by that. So somebody has to tell me what's 2.7 times 4. I don't know. 10.8, thank you. 10.8. And then I also need f of 1. I'm pretty sure I can figure that one out. 2.7 times 1 squared. 1 squared is 1 times 2.7 is 2.7. So I can make this an easier problem than by saying, okay, f of 2 is 10.8 and minus f of 1, which is 2.7 over 2 minus 1, which is 1. I'll just write it that way. And then I just don't even have to do a lot of arithmetic as I go. What is that? 8.1. So our m secant is 8.1. Now we have to interpret what that means. What does that mean? When? When? Okay, yeah, yes. Tell me more, Emily. Right, and it's meters per second, but that is a second. So, or meters? No, it's feet. Sorry. Yes, I was like, it's not meters. So, between 1 and 2 seconds, you travel at a rate, an average rate. Or average, just a second, average rate of 8.1 feet per second. I was going to say, how do you know? Yes. My gosh, don't you watch the movies where we like have to go to Mars and the Earth is dying and all this other stuff? Okay, so problem 2. Shh, you do this one. See if you can get this one. Same thing, but from 2 to 3 seconds. So redeem yourself if you got that other one wrong. Between 2 and 3 seconds now. You can redeem yourself if you didn't get that to work before. I'm not sure. I did not. I actually did not wink. And all the people, anyone who's listening to this recording will validate that for me. I'm just kidding. No, I really didn't. Yeah, I did respond, but I didn't physically wink. Okay, do you have an answer? Who has an answer? Yeah, yeah. Yep. Yes. Yes. Yes.
I think I did good
Yes.
for one.
Yes. Did you get one, Max? No. Sure. Yes, I know. Did you get it? Yeah. Okay, so here's what this one is. The f of 3 minus f of 2 over 3 minus 2, another 1 second interval. 3 squared is 9. 9 times 2.7. What is it? Okay, and 2, I knew, I forgot, 10.8. And, 3 minus 2, yeah, is 1. And what was that? Feet per second. So, just a nice kind of reminder that this is truly a curve. So when I pick different 1 second intervals, I'm going to get different slopes, right? Or rates of change. Does that make sense? Because I'm going to be steeper and steeper. And if I go out further, it's even going to be steeper and steeper. And, as we look at that. Okay. Tomorrow, bring it, your Chromebook charged? Or whatever it's called, or I don't know. Well, I am announcing to you that it has to be charged. And so, you know what? The easiest way to lose credit in math class is not to have your Chromebook charged when you have to take the STAR test. I'm just saying. That's right.